Hello everyone, welcome to Sundray SCWA training. This session we're gonna talk about WLAN optimization. This session has three parts. First part is the problem we can solve by WLAN optimization. Second one is the WLAN optimization for different scenario, and the third one is the some cases share for the optimization. Um, in a large-scale wireless net project, after we finish the project during the acceptance period, we need to do the optimization. That is very necessary. So we make sure that clients they are happy with the project we have done, and the Wi-Fi coverage, the signal, and the speed always meet the client's requirements. Here are some case studies, and because lack of the property optimization and fail to the acceptance, the client they don't want to accept this project, so it will be hard for the close project. First one is the client. It's customer. They need a wireless network in a exhibition hall. We know that in a exhibition hall there's high ceiling, and ours the founders they store the AP, but they find out for the phones or other devices they only support 2.4G. The speed is very slow. It's very hard for them to open a web page with that wireless network, and the acceptance of course is failed. uh, Also another customer they need to provide the wireless coverage for their factory, and in that factory they have laptop, they have the scanners and other wireless terminals needed to connect in that workshop, and also they have the high-speed download, this kind of requirement, and the roaming for the scanners, but due to the lack of network optimization, and also uh, the not the properly site survey is the beginning stage of this project. The acceptance is haven't be passed at the first time, and also the government agency they need us to have the Wi-Fi for their office, uh, but when they do the deployment, they install the AP in the corridor, in the hallway, so the coverage inside of the office is not good. So the acceptance also failed. Okay, now let's say that the problem we can solve by the optimization, because this optimization is really needed for the project. First type, the question is like wireless delay is large, and the wireless is easy to lose the package. The speed is super low, and the roaming effect is bad. For this kind of the type the problem, maybe we need to adjust AP's position. Sometimes we need to end the AP in specific area. Sometimes we need to change the AP's model. And also it's like other problem like the photo page or the repeated authentication. For this kind of optimization, we can just do the configuration, change the configuration. So we hope that the first type of the problem cannot happen to our projects, because this is the thing we try to avoid when we do the static survey. But when it happens, we need to know what we can do. First one is sufficient signal coverage. That's mean in some area, in some place, the signal is weak, and that place need a Wi-Fi good Wi-Fi speed. So this is the problem. Uh, the problem like the you put the AP into the corridor, uh, or the AP signal is be blocked by the big obstacles like the metal ceilings or load bearing walls, and also like their directional APs, the direction is not faced properly, and also the AP position, the AP is stored too high. Commonly, usually our AP is be installed our omnidirectional. I mean indoor AP. All our indoor AP except the S70D is directional. All our ceiling AP is omnidirectional. For the omnidirectional AP, we prefer like it stored is around 3 to 4 meters. Not recommend to store that AP at a very hard position. And also if the PoE supply to the AP is too weak, I mean the cable is too long, it also can cause the insufficient power or supply to the AP. The AP there to be a weak signal. And also high channel utilizations. Even if we have the AP here, the signal is very strong, but the speed is very low. So that possible reason is the channel utilization. This kind of the channel utilization, high channel can be caused by the AP that like the space between the AP is too near, or there's other brands APs near to the our AP, and also like other Wi-Fi signals like the no 802.11 interference from like Bluetooth speakers, wireless cameras, micro ovens. This also can cause the interference for our Wi-Fi products and make our wireless network slow. If you know this tool, we call it the fluke wire tester. This one can help us to find out where is the source of this interference. First one is lower negotiation rates. I'm yeah, like the if you do some client, we are scared. Okay, like my phone that you said that your AP's speed support up to 1 gigabit because it's 11 AC. While when I connected the max speed, the maximum speed I get is around 70 Mbps. What is the reason? So first one like maybe it's a signal stress. It's not enough. Second one, the channel bandwidth is very important. Because when we talk that one AP can support 1.3 uh, gigabit per second, that's me this AP needed in working in a wide uh, channel bandwidth like the 80 Hz. And those like protocol. If their phone or terminal only support 11N or 11BG, the speed is like 45 Mbps. It cannot be higher. Also the MIMO. For this, we know that the 1.3 gigabit for the 2 point, that is for the 2 by 2 MIMO devices. It can be in the only like 5G, it can support 800 Mbps. So the protocol, the MIMO, is also can affect the speed of a terminal. Mm, and also network adapter driver. Sometimes like the most of the laptop had good speed, but only like the one or two older laptops, speed is slow. So that is the problem of that network adapter. We also need to consider these things, and also the space loss. We call that as signal stress. Yeah. Lower negotiation rates what we consider about this spatial loss, free spatial loss. For this one, we just have like basic understanding is okay, like the 100 meters, uh, 80 dB, 80 dB, 80 dB signal will be lost, and in the 200 meters, 86 dB will lost. Here's a 60 dB rule. I think we already talked about this rule in our first second slide. And the poor roaming is also a problem. Sometimes when you're walking, we keep disconnected from Wi-Fi. So this one for the better roaming, I remember that we suggest that between these two AP at the middle point of the two AP, the signal should be stronger than the stronger than the negative 65 dB. So the deployment, the position of the AP is very important. And also, if client want to have the better roaming, we can configure it in the tunnel mode. And also sometimes the internet speed becomes slow. The web page hard to be visit. This also because of the bandwidth is not enough. So when we do the WLAN optimization, sometimes we need to consider other devices that work with our products. It's not the problem, maybe not only caused by our devices. It also can be from like the firewalls, the connections, the sessions, or the bandwidth is not enough. This all can be the possible reasons. Now let's go into the second part, the optimization for different scenario. First one is in the office. In the office, remember that we need to do this thing. Test the signal under the AP. If you install AP in the ceiling, just go there and standing under the AP and make sure the signal come from this AP is greater than the uh, signals from other APs by 5 dBm. If there are some other APs, they have signals and the signal stress is almost same with the AP right we are testing right now, that have the conflict. Definitely they have interference to each other. For the main coverage area, we need to make sure there's no more than one AP in the same channel, co-channel interference in this same channel, no more than one APs. Same with 2.4G. And between the APs, AP1 and AP2, the signal stress of both AP need to greater than the negative 65 dBm. In the classroom, same, but this is other AP. We see the 3 meters because we know the AP yearly the classrooms, the height of the classroom, the height of the classroom is around the 3 meters. So either the AP, your signal from this AP should be 8 dB higher than the 3S of the other APs. And also in the classroom, we need to make sure that there's no more than one APs. The core channel APs is not more than one. And the signal stress should be uh, 50 dB greater than the signal from the neighbor classroom. And for the workshop and warehouse scenario, uh, under the AP, this signals stress stronger than RABs by 5 dBm, 5 dB, and also the no more than one co-channel APs, co-channel APs, and between the AP1 and AP2, the signal stress to both AP should be greater than the negative 65 dB. This one can make sure a good uh, roaming. For the hotel, the coverage stress recommended is negative 40 to negative 60 dB, and the signal stress of the other APs on the same channel, this maybe the signal come from the other room, cannot be greater than the negative 65. Last part is optimization case introduction. This is what is project in office area. At the beginning, according to the design, we put the AP in the corridor, and the user experience really bad. So what the reason for this one? First one is the lower signal stress inside of the office. The terminals inside the office get the weak signal, and of course, it will cause the lower negotiation speed. The devices with the lower negotiation speed will occupy the channel resource. That result in the almost all the terminals don't have the good Wi-Fi speed. Second one is the signal. After the signal penetrates the walls and it become weak, right? When the several APs signals penetrate the wall into the same spot, when the user's phones connect to these weak signals, they will keep doing the roaming. So from one AP straight to another AP, so the user will disconnect it all the time. So what is our optimization solution? First one, we can use the power division solutions. That we use the S5 S515. Do you remember that AP has 8 connectors? You can connect the feeders, so we can use the one AP to coverage 8 rooms. And then in some important area like the directors or leaders office, or sometimes in the conference meeting office, we can put one inward AP per room. And also in some large office, we can use the AP that used in the corridor. Before we just move that AP inside that big office room. So in this way, we can provide good Wi-Fi coverage and the speed of Wi-Fi for our user. So after this optimization, the project is finished and the client is happy with the result. So this is the or for this optimization. So you can say that for optimization, sometimes we need to change the AP position. We needed to change the AP's models. So that also tells us how important is a good size survey. Make good size survey at the beginning, so we will have the list. We should no need to do too much work while we do this acceptance for the project. Okay, thank you.